Yeah, good morning, everybody, to our lecture in macroeconomics after a long weekend. I hope you also enjoy it. I think we had quite nice weather for the end of October. And yes, at first, I want to remember you that on next Monday, oops, I organized a talk with Dr. Jörg Rahn about investing within the business cycle. And yeah, actually, since we not really know where we are in the business cycle, because almost everybody forecasted negative growth rates for the next 2, 3, or 4 quarters, and now the first quarter of these supposed to be negative quarters is out, and surprisingly, it's positive. So we will see if the deep crisis is coming or if it's not coming, because on the other hand, inflation rates are going up. And this is, of course, bad for demand in general. If still we are already in 2-digit inflation rates and the inflation rates even become higher and higher these months. So I think this will be really interesting if somebody coming from an institutional investor with billions of euros behind it will talk about what to do in order to supposed to not lose the money the next years. Okay, and then I talked about the diamond and dipfig model. This I have to change so it's better. Last week, and I made a mistake. I have to admit, and therefore I made a video about the diamond dipfig model, and I think it's still converting. Let's see. So almost. So we will see. I upload it and then I will send you the link for the explanation of this model, and I will show you where my mistake. Actually, I have to admit I should have seen it because when we started, let me show it for you, and let's take a new color. Let's take violet, for example. So what we did were that we calculated now it works, that we calculated the two Nash equilibria in pure strategies, and then we calculated the Nash equilibrium in mixed strategies, and for this we obtained this condition here, that if both players play with probability alpha star equals 1 over 1 plus 2 times the interest rate, the strategy hold and to take the money, then nobody has incentive to deviate from these mixed strategies. And let me also recommend that this, of course, is only within the interval of 0 and 1, so that we can interpret this as a probability if I is larger than 0. And remember, the time hasn't been very long past by where we had negative interest rates. So this is then, of course, a general assumption that we think, of course, always nominal interest rates should be positive, but we had the last 10 years also a period where this interest rate were negative, and then, of course, the assumptions of these model do not hold anymore. But right now we are again in a scenario with positive interest rates. And then I introduced this equation for the learning process. And there we said that in every period, the guys compare what would they earn if they hold the money, or if they do not know anything about what the other guy is doing. And also myself, we play the strategy alpha t, and due to this difference, if holding the money would be larger, then I would increase my probability alpha to hold the money, and in the other case I would decrease it. And if we look at this difference has the unit payoff, and then I add some number with the unit payoff to a number which is a probability. So let's say this is unit probability. And for this, of course, I add two numbers with different units, and this, of course, is not allowed. And for this, the learning equation, we have to slightly modify it because we interpret this difference here of the payoffs as the weight of how much we change the probability. And therefore, we have to add at this point also an alpha t times, and then in brackets, these difference. But all this you see them in my video I recorded the last days. And then, of course, these alpha has to be added in every calculation. So here, alpha t in front of it, here, alpha t in front of it, and here, alpha t in front of it, and of course, in the last line, and then the difference equation looks like it has to be. And also at this point we have to add alpha t, and this is then the equation for the learning process. Well, nothing changed due to the interpretation, because still the main thing of this difference equation is if these brackets are larger or less than 0. And with this equation, then we can go to our Excel sheet, and therefore here this is the absolute difference between holding money and taking the money, and then this difference has to be multiplied with alpha times 1 minus alpha. And this I missed the last time. And if I add this then here and iterating these difference equation in time, then we obtain the following pattern of the evolution of our probability to have a bank run. So what I plot here is the probability 1 minus alpha. So if alpha is the probability that I hold the money, then 1 minus alpha is the probability that I do not started the recording, I think, or no, it has started. Okay, there, because I haven't seen the button here at my laptop. So then 1 minus alpha is the probability that I take the money. So what we see here is, what is our starting value of alpha? Our starting value of alpha is 85%. What we had calculated as the critical value, so the value of, where we are, oops, I think I have to, oops, this one, and there, that you can better see it. And now you can better see it. So almost. Well, then I have to move it a little bit. So the critical value, if we have an interest rate of 5%, we calculated the critical value, the probability of mixed strategies to 91%, 1 over 1 plus 2 times the interest rate. And if we are starting with probability below this critical probability, then we see, and here, that well, let's move this here, just in here, then it's easier. So, and I do not have to move the Excel file. And here, okay. Then we see that over time, the probability 1 minus alpha, starting from 0.15, increases during time. And in the end, we end up with a bank run. And if we now, we can play a little bit with these probabilities. If we move towards the probability of the mixed strategy equilibrium, let's say 90%, then we see that the increase of the probability is much lower than if we move in the other direction. So let's start with, let's say, 60%. So then you see almost after, let's say, 10 days, we are almost in the bank run scenario. And then if we flip to a probability larger than the mixed strategy probability, let's say 9.5%, then you see that we switch also during the development over time in the stable scenario where nobody takes his money. So this is then a model where you can explain, well, how probable is it that we, will be after a while in the bank run scenario or in a stable scenario. And also what is really interesting in this model, that we can model how fast we are going, especially in the bank run scenario. So let's go back to 85%, because of course when we see that the people start running to the bank, then of course we can do something about it from the government if we see it. And then we see also if this starting probability is in the neighborhood of the mixed strategy probability, then we have some time to interrupt this process. And actually we saw something like this during the financial, or better the euro crisis in Cyprus, because there we had really a shutdown during time that the people ran to the bank because they thought that the whole financial system in Cyprus would go insolvent, and then the government really prohibited during some days the people in their country to go to the bank and withdraw their deposits. Okay, so I also said that I recorded a video, and you get also the link for this video. Then let's go further on in our lecture, and there we talked about the Fisher relation. Let's just shortly summarize this again. And oops, I have to reduce this again. Now you see it better. So what was the Fisher equation? There we said we had at time 0 investment K0 with an interest rate I. But during making my deposit and holding the money for one period, also we assume that during this time prices are increasing with inflation rate pi, interest rate I, and inflation rate pi. So what happens then? I'm investing at t equals 0. So K1 will be then K0 times 1 plus I. Of course, if my interest rate, we assume that this is larger than 0, then of course K1 is larger than K0. But what really counts for me is how much goods and services can I buy next period in t equals 1 compared to today at time t is 0. So if during time prices have increased with the inflation rate pi, then in order to compare these two values, so how to compare K1 and K2, K0, so what is better with which amount of money I can buy more goods in the specific period. For this, we analyzed that we have to calculate the present value of K1, but now not with the interest rate, but with the inflation rate. So for this, calculate the present value of K1 with inflation rate pi. So what we then have is K1 over 1 plus pi, or we can say discount K1 with the factor 1 over 1 plus pi. So this is how you technically calculate the present value. I think you have done this in your math course in your first semester. And this then equals K0 times 1 plus I over 1 plus pi. And the value which we calculated here, this we interpret then as the real value of K1 with respect to the period, to the former period in t equals 0. And for this, we just say then that this should be K0 times, and now 1 plus R. So 1 plus R, and R is then the real interest rate. And then, of course, we see that K0 cancels, and we obtain 1 plus I over 1 plus pi equals 1 plus R, and this is the famous Fisher equation. And, well, I think you don't remember this in this form, because we can then make a heuristic approximation that we say this we can also write as 1 plus R times 1 plus pi equals 1 plus I, and then we obtain 1 plus R plus pi plus R pi equals 1 plus I. The 1 cancels, and we assume interest rates and inflation are low. This means smaller than 10%. Then if we think 2% times 4% is much, much smaller than 2% or 4% itself. But here we have the sum of then 2% plus 4% plus a number which is much smaller than these two numbers and also the number of the right side, and therefore we leave this product of interest rate times inflation rate. We just leave this approximately out. Then we can approximately cancel r times pi, and then we obtain the well-known dependence between real interest rates equals the difference between nominal interest rates minus inflation. Real interest rate equals nominal interest rate minus inflation. And this is then, I think, the form of the Fisher equation you remember in general. But of course, we have to keep in mind this is only approximately true if interest rates and prices increase or the numbers for these variables are below 10%. Well, and just I think yesterday, the Statistic Institution of Germany and Europe, they published the new inflation rates, and the actual inflation rate in the Eurozone as a whole is, I think, 10.7%, and in Germany for October it is in the flash estimation 10.4%. So again, here we are outside the assumption that this is a good approximation. And this you always should keep in mind if you are arguing that something happens because of a model, because you always have to think what are the assumptions behind your model. And sometimes, actually in times like this, during the last 10, 15 years, especially in the development of the economy and in macroeconomics, yeah, we had really different times, and we have still different times, because also these highly increasing inflation rates are, yeah, the first time I showed you the longer time series. The last time we had in the developed countries in the world inflation rates with 10% or more, this has been in the 1970s, so 50 years ago. Okay, so then let's go on in the lecture, and what we have also talked about, we talked about in general what is money, and there we talked about the functions of money, and Then the motives of holding money, where the money demand comes from. And there also we talked that gold in general has the properties which we need, that we can call this good money. And now we want to talk about, yeah, what is money today? Because we are not anymore in a system where we are backed up with gold or silver or something like this. And so we want to talk about the modern understanding of money, because a very long time, at first we had coins, then we introduced some roughly around 500, 400 years, we introduced paper money, and then actually the paper money really increased during the time of the Industrial Revolution, so around 150, 200 years ago. But during all these times, this paper money was backed up with gold or with silver, and we had until the World War II the so-called gold standard. This meant that every country, every central bank backed up their own currency with money. So you had the right, here is my money, I want to exchange these into gold. Then after World War II, we had the worldwide anchor for the Western countries of the US dollar. So we had a fixed exchange rate system that, so to speak, I think around 5 German marks or 6 German marks for $1, and then you can exchange your currency into dollar, and then you had the right to exchange this uh, in the United States to gold. But also this system we skipped in 1973. And what is money now in our modern times? Money is only the promise, well, of the central bank. But who owns the central bank? Of course, the countries. Here at the ECB, the members of the Eurozone own the ECB, and, well, in whom then we trust that our money has a value? Of course, we trust in ourselves. We trust that our countries are stable, that our countries are there also tomorrow, and especially that we are finance our countries, and this just means that we regularly pay our taxes, so that our countries do not become insolvent. So money is now more or less a promise to ourselves. And in the end, a promise to ourselves. And for that, we speak of so-called fiat money. And this is a mixture of Latin and English. Do you know what fiat means? Somebody religious, so, or Christian, and you know the Pater Noster. There you have the sentence fiat voluntas tua. This just means your will should happen, or God's will should happen. So this just means money just happens. So we create money just out of our promise to ourselves. So there is no backup, there's no anchor behind it. We just hope that the sun is rising tomorrow or that our country will be there tomorrow. So, and then after we, from a philosophical standpoint, we explained what is money today, and this you always should have in mind if we talk about money. But now we want to talk then when you are reading in the news, in the media, the amount of money is increasing by, let's say, 5% compared to the last year. What does it mean? What do we count as money? And for this, we distinguish four kinds of money aggregates. And the first one, M0, this is nothing else than our cash, so our coins and paper money. Well, I think I can switch to black again. Well, if you go to the web page of the ECB, then you won't find there a definition for M0. Well, you can think of yourself. How much goods and services are you still paying with cash? And this is, I think, also for you, or even for you because you much younger than me. There are not many goods and services left which you are paying with coins or with paper money. Or if you go especially actually to Scandinavia, to Sweden, for example, there you almost cannot pay anymore very much things with coins or with paper money. And also, I think the Dutch government decided that if you sell your goods and services, you do not have to take paper money anymore. You just can say, well, I only want your credit card. And so this is really starting to change what will happen to our cash money in the future. Because also you have to think, if we then go to the money aggregate M1, then of course we take also as money the overnight deposits, and this is nothing else our bank cards, credit cards, and so on. I think also these kind of things which you pay most of your goods and services. So, and this of course increases the amount of money, because if I take my wallet, here is my cash money inside, and then at my banking account, I don't know, I have 1,500 euros or so, then of course I can always with a credit card or with my bank card, I can buy things for these 1,500 euros at my overnight deposit bank account, and then this of course counts also as money, because with this amount I can exchange this amount, 1,500 euros, to some goods and services, buying shoes, jeans and so on. And then we go further to M2, and here we take also deposits with a longer maturity. So about 3 months and other maturities up to 2 years. And why do we also count this as money? So you cannot just say to your bank, when the maturity is 3 months, I take the whole amount today and I close this deposit, because then you have to wait 3 months. But on the other way, think about you want to buy something expensive, let's say an expensive washing machine or something like this. Costs you €1,000. On your overnight deposit banking account, you don't have these €1,000, but then you have a saving account with a maturity of 3 months. And then, for example, you can say, well, you see here, I have at my savings accounts, let's say €2,000. With this, I can pay you in 2 or 3 weeks. And then, of course, in general, you can also buy this washing machine today. Because in most cases, if somebody sees, well, he is able to pay me in 1 or 2 weeks, then you can also buy this good, the washing machine, also today. And therefore, we increase this maturity to longer times. And in the end, we go to M3. And in this case, then we also look at the interchanging process within the financial institutions, between banks, between insurances, between hedge funds, and so on. And they also just interchange money market funds, debt securities, and here we also take the limit in general of a maturity of 2 years. And if you read in the news that money is increasing by 5% and nothing else is written down, then we in general speak of the money aggregate of M3. So this is the general money aggregate when we talk about how much money, how much euros do we have. So this is M3 is the general aggregate if we talk about the amount of money otherwise it should be said that we talk about another aggregate. Well, actually, in very volatile times, then of course it is interesting also to look at the money aggregate of M1, because why? Remember again our bank run model. In very volatile times, then I want to hold, or in general, I want to people want to hold their deposits in accounts where they can every day go to the bank and withdraw the money. Think again about the probability that you think the bank is not there tomorrow. The bank has a probability to get insolvent, and if you hold then your money in accounts with a maturity of 1 or 2 years, and the next 6 months your bank gets insolvent, then you don't get your money back. I think I told you Lehman Brothers, you got out 8 cents out of $1 afterwards. After they got insolvent at I think 16th of September 2008. Okay, then when we have defined money, let's see how much money, and here especially how much euros do we have, and the actual numbers from August 2022, we have an amount of M3 of roughly 16. Oh, this has to be, we are in the English course, so this has to be trillion. Trillion euros. And let's think about, yeah, is this a reasonable amount of money, or why do we have a number roughly 16 trillion euros? Well, and for this, we can think of what we are doing with this money. So question, is this a reasonable amount of money? So what we are doing with this money, we exchange money for goods and services. And there you should remember something. We talked about goods and services and counting goods and services within this lecture, and at what in which aggregate we counted goods and services, in which central aggregate we looked at. Yep. Yes, of course. So then, how large is GDP of the Eurozone? So let's see if we can exchange all our goods during one time with this amount of money. So, well, of course, we are here in Germany, and therefore I showed you in detail the numbers for Germany. Then let's start with Germany. And then we want to have the whole Eurozone. And let me try to draw this. So we start here with Spain, France, then we come to Germany, Denmark, Scandinavia, something here, Russia, Italy, oops, and Greece, yeah, something like this, and here, no, this is not good. So this is maybe Germany. Which countries are in the Eurozone? Of course, we have Germany. And also we need here, this should be Great Britain and Ireland. What are the large countries of the Eurozone? Germany is inhabitants and economically the largest. France. Next. So here we are. Then this is Germany. This is France. Italy, yes. So this is then somehow this. The next largest economically. So we have 19 countries. Also Malta is also in the Eurozone. You should travel more. Well, we had 2 years where we cannot, where we could not travel. I know. Yeah. Which of the Scandinavian countries is in the Eurozone? There's only one, or yes, there's only one country in the Eurozone. It's only Finland here. So Finland it is not, I have not drawn it good. But Finland is economically a very small country. So Spain, we have here. Well, and then we can say these are the 4 large countries, and then we have medium-sized countries, and this is then here the Benelux states, Holland, Belgium, and of course we have then here Austria, and these are then the medium-sized countries, and then of course we have the small countries. Let's say we start with the small countries, Portugal, Greece, and then of course countries like Finland, and a medium size is of course also Ireland. So these are the large ones. Then medium, let's say this is the Netherlands, Belgium, and Ireland, and also Austria. And then we have small countries like Portugal, Finland, and so on. And of course, then very small countries like Cyprus or Malta and Luxembourg. So, but now we want to estimate roughly the GDP of the Eurozone. And so I ask you, what is the GDP of Germany roughly? Do you remember this number? You can also look it up. Yeah, not anymore. It was 4 trillion US dollars when we went back about a year. But now the exchange rate flipped to the other side. So the number for Germany in US dollar is even less than the euro number for Germany. Almost. So the actual number was 3.6 in 2021. So trillion euro. So, and then, of course, we can just look it up, type it into Google, and you find directly the number. But now we want to try to estimate it without looking into the internet. How large would be roughly the GDP of France? And there you can think of, maybe you know a number relative of France to Germany, and from this number you maybe can calculate an estimation for the GDP of France. So what is more or less a general number of a country which is highly correlated to the amount of GDP? There we talked also about GDP when we talked about GDP and GNP, so the net gross national product. Yes, yes, of course. So, and how much inhabitants has Germany and how much inhabitants has roughly France? Maybe you know this. Germany? We have some Germans here, right? Pardon? Yes, great. Yep. So Germany has roughly 83. And France? Somebody knows it? Well, they have much more children than Germany, so they are closing up to Germany, but still, I think it's roughly 65 million. And Italy is a bit less. I think it's roughly 60 million. So, and since this is highly correlated, then you can say, of course, France then will have a GDP maybe of 2.5 trillion, because 2.5 divided by 3.6 is roughly the same as if you divide 65 through 83. And well, let's say Italy, it is a bit smaller, but is also roughly 2.5 trillion. And Spain has, I think, roughly 35 million. And then we are, I think, roughly at 1.5 trillion. Maybe somebody can just look it up if I'm right. And if you all add up this, then we are here, let's say 3.5, then we are at 6, then we are at 685, now we are here at 10, and if we want to have it in total, we have to know roughly inhabitants of the Eurozone. Do you know this? I think so, something around this. So I think it is almost 400. Well, and if we take this number, almost, well, roughly, well, let's just look it up here. So what is the inhabitants of Eurozone? Oh, a bit less. So 340. Let's say roughly 350, then it's easier to calculate. And for this, then we could say that Germany is roughly 25% of the Eurozone, and multiplying 3.6 by 4 is then 12, yeah, let's say roughly 14 to 15 trillion euros GDP Eurozone. So this would be our estimate. And now let's go again to the World Wide Web and let's see, what is it? Well, we are around, but this is US dollar. So we need it in euro. The indicators, this is all US dollar. Then let's take the official data. So let's go to Eurostat. This is the statistics institution. Do you see this? Yes. Oops. And then we go to economics. Let's switch to English here. So then economy and finance. You see this? Yeah. National accounts, annual accounts, main GDP aggregates, and let's see, Euro area 21, 19 countries. So we are here at domestic product at market prices. Let's see that we are in the right aggregate. This you should also see. So here, gross domestic product at market prices. So this you also always have to look up that you are not in real numbers, that you know what you are talking about. And so we are here at 12 billion euros. So then we have estimated it to roughly 4.14 to 15, and the official number is roughly 12 trillion euros. And then you see, is this number reasonable? Well, we have here two numbers, GDP of the Eurozone and the amount of money, the money aggregate M3, that they are roughly in the same neighborhood, these two numbers, and therefore we can say, well, this is a reasonable number because we can, with this amount of money, we can buy our goods and services we produced in 1 year in the Eurozone. Okay. And yeah, what we did here is more or less that we estimated, or that we ask ourselves, is this a reasonable number? That we looked at the main functions of money, and this is just to exchange goods and services with the good, the central good, money. And behind this is the so-called quantity theory of money. Maybe you have already heard in school or something there about this theory. And what is this theory about? Well, we say we have our total amount of money times how often within a period I can buy goods and services with the same euro. Because, of course, when you are entering some shop and you buying today something, then the guy of the shop can buy with this amount of money tomorrow something. And therefore, we multiply the amount of money with the velocity of money. And what we are doing then with this number, the amount of money with velocity, means how often can I buy with the amount of money, goods and services? Well, then we say just everything what we have produced, and this is nothing else than here price level times the quantity, and the quantity we yeah, can estimate by real output. Remember, real output was that we want to cancel the price effect on it. And in general, we would say velocity of money, this is for quite a while more or less constant. When is the velocity of money changing? Well, when we make some innovations. Of course, when we invented something like a credit card, then the velocity of money, the velocity of money increased, because before we had credit cards or bank cards, then I always had to go, before I can buy anything, I had to go to my bank, withdraw an amount of money, and then go to the shop. And right now, I just backed up with my bank account, and I can go directly I can go directly in the shop. Or if you think about innovations like PayPal, Google Pay, and so on, this also increases, of course, the velocity of money, but these innovations doesn't happen every year. And therefore, for a short period, we can more or less say that the velocity of money is more or less constant. Well, of course, real output is changing. But now we compare how large is the change of real output compared to the change of price level. And there, actually, if we look at our times here, then we could say, so in general, and also if you look at historical time series, then we can say that price levels, that price level changes much faster than real output. Remember again, we had this aim that we roughly increase between 1 and 3% per year. But this also means that we are that we increase quarter on quarter much less, and also prices during 1 month or during 1 quarter are much more volatile. So inflation goes up and goes down within a year. And therefore, if we compare this, then we can say that the change of real output is much less than the change of the price level. So also in the short run, we can set then real output growth as more or less constant. And what we obtain then is, of course, that we have to more or less a one-to-one mapping between the total amount of money and price level. And this is, yeah, the famous dependence that we just say, if we start to print money, what happens in our economy? just prices are increasing. Well, and later on, I will show the balance sheet of the ECB. And this is, yeah, maybe the anchor of money, the balance sheet of ECB. And since the financial crisis, it hugely increased. And during the last 10 years, we always looked at the increase of the balance sheet, not only of the ECB, but also of the Federal Reserve. And there, this doubled 4 times, I think, compared to the starting point in 2017. It's, I think, 8 times higher than before, than in 2007. The balance sheet of the large central banks. And there, if we looked at this theory, we always thought, well, prices have to increase. And they really didn't increase. And right now, they really started to increase. And this, I think, I also already said that the huge increase of prices which we right now have is not only due to the rise in energy prices, but also from a theoretical standpoint, just an easy interpretation of this quantity theory of money. There was a question, or? Yeah. Yeah, yeah, yeah. Yes, yes. And of course, maybe this was true in the short run, but then of course you have to withdraw these money you have printed, and this we do not do right now. And then I think, and this is my opinion, we cannot be really surprised that at some time prices really started to rise. We didn't knew when it happens, but due to monetary policy of the large central banks in the world, there more or less it was clear that at some time prices really have to start to rise in a velocity we don't want to have. Okay, let's look at it in a bit in a more formal way. There we say this is M, the amount of money. V is, of course, the velocity. P, price level, and Y should be real output. Then, of course, we can rewrite this as the amount of money is P times Y is more or less GDP divided by the velocity of money. And then we have here a dependence of M on Y, P, and V. And if we again set V as constant, then we can interpret this equation just also as some kind of a money demand function. And then, of course, we have here the coefficient 1 over the velocity of money. And this we interpret then as our cash holding coefficient. Of course, if V is constant, then of course also K is, at least in the short term, constant. And then we can assume that in the short run we just dependent with our demand of money on the level of transactions, because nominal GDP is all goods and services at market prices for final consumption within a year. And then we can, of course, again divide our nominal demand for money by P, and then we obtain the general money demand function, now only dependent on income on Y. Because on the other side, remember the three different approaches. We can interpret this as output, and on the other side, we can Y also, of course, interpret as income. Only dependent on one variable, and Y can also interpret it as income, and compare this money demand function with our other money demand function, which we deduced. I think I have it also here. Up. Here. We deduced the money demand function from the speculative motive, precautionary demand, and transaction motive as dependent on Y and I. So, and this we later on, when we look then at theoretical models, this we use as the Keynesian money demand function, and later on we looked also at the neoclassical model, and of course the neoclassical economists, they think modeling the money market in the right way is using the quantity theory of money, and therefore this we interpret then as the neoclassical money demand function. Okay, then we are done for today.